Hi, welcome to the continuation of our Master Crammer Calculus Made Easy series, and topic for this video is about limit laws. So, let's start with our first limit law. We can see here the limit of a constant c as x approaches a is equal to c. So, for example, I have the limit of 7 as x approaches 1 is equal to 7. So that means a limit of a constant as x approaches a certain number is always equal to a constant. Our next limit law is limit of x, or a variable x, as x approaches a certain number is equal to that number. So for example, the limit of let's say x as x approaches 1 is equal to 1. Next will be the limit of a constant multiplied by a function as x approaches a is equal to the constant multiplied by the limit of the function as x approaches a. So basically what we did, we just placed the constant outside the limit. So in this case, it becomes the constant multiplied by the limit of f of x as x approaches a. So for example, let's say the limit of, let's say, 5 multiplied by a function x squared as x approaches 1. What we can do here is that since this is a constant, we can put it outside the limit expression. It will basically be the 5 multiplied by the limit of x squared as x approaches 1. So we can take the limit, in this case, of this function or expression as x approaches 1, multiply this now by the constant 5. Next, the limit of the sum of two functions as x approaches a is equal to the sum of the limit of each function. So to illustrate, let's say we have a limit of x squared plus x plus 1 as x approaches 1, for example. What we can do here is we can treat x squared as f of x, and we can treat x plus 1 as g of x. So what do we got here? What do we get here? We have now the limit of x squared as x approaches 1 plus the limit of x plus 1 as x approaches 1. So what we did, we separated x squared and x plus 1. We get the limit of x squared as x approaches 1. In this case, we have this expression. And then we take the limit of the other two terms, x plus 1. It will be limit of x plus 1 as x approaches 1. Pretty straightforward. Next, we have the difference now. The limit of the difference of two functions is equal to the difference of the limit of each function. So let's say we have here the limit of x squared, okay? Let's say minus x plus 1 as x approaches 1. This can be written as, we can again treat x squared as f of x, and then g of x is equal to x plus 1. So we can rewrite this as the limit of x squared as x approaches 1 minus the limit of x plus 1 as x approaches 1. Next is the limit of the product of two functions as x approaches a is equal to the product of the limit of each function. So in this case, as an example, we have the limit of, let's say, x squared multiplied by, let's say, x plus 1 as x approaches 1. We can treat x squared as f of x and x plus 1 as g of x. So this one, x squared, we treat it as f of x, and then this x plus 1, we treat it as g of x. So now we can now split this into the limit of x squared as x approaches 1 multiplied now by the limit of x plus 1 as x approaches 1. Another example, which is similar to this, to our previous limit law, is the limit of a quotient of two functions as x approaches a can also be expressed or is also equal to the quotient of the limit of each function. In this case, the limit of f of x over g of x as x approaches a is equal to the limit of f of x as x approaches a divided by the limit of g of x as x approaches a, provided that the limit of g of x as x approaches a is not equal to 0. Because if this is equal to 0, then this whole expression will be undefined. So we have to make sure that the limit of g of x as x approaches a, which is in this case our denominator, should not be equal to, or must not be equal to, 0. So as an example, we can put, like, for example, limit of f of x, let's say x squared, and g of x can be like x plus 1 as x approaches 1. We treat here x squared as f of x and x plus 1 as g of x. So what we did here is x squared is f of x and x plus 1 is treated as g of x. So in this case, this is equal to the limit of x squared as x approaches 1 divided by the limit of x plus 1 as x approaches 1. Now, next limit law is the limit of f of x raised to the nth power as x approaches a is simply equal to the nth power of the limit of f of x as x approaches a. So as an example, let's say we have limit of x plus 1 raised to the, let's say, third power as x approaches 1. This can also be expressed as the limit of x plus 1 as x approaches 1, and then you raise this whole expression to the third power. So the limit in this case of x plus 1 raised to the third power as x approaches 1, you can simply express this. You can get the limit of this expression x plus 1 as x approaches 1. In this case is what we did, limit of x plus 1 as x approaches 1. After you get the whole limit, you raise it to the third power. Similar to this, by the way, you have to take note that n is a positive integer. So positive integers are like 1, 2, 3, 4, 5, 6, and onwards. Next, similar to this limit law, will be this limit law wherein the limit of the nth root of f of x is equal to the nth root of the limit of the same function as x approaches a. So in this case, let's say we have the limit of the cube root of x plus 1, for example, as x approaches 1. This can also be expressed as the limit of the expression here, x plus 1 as x approaches 1, and then you take the whole cube root. And take note, n, in this case the root, should always be a positive integer, meaning 1, 2, 3, 4, 5, 6, 7, and onwards. And another rule here is that if n is even, the limit of f of x as x approaches a should be greater than 0. So for example, if instead of 3, which is an odd number, let's put let's say it's 2, for example. So no need to put 2 if it's 2, then it's automatically it's square root, but just for illustration purposes, 2 is an even number. So here, this x plus 1, or the limit of x plus 1 as x approaches 1, should be greater than 0. Because if it's negative, then you'll be getting the square root of a negative number. So I hope that you guys learned a thing or two today concerning limit laws. More examples about limit laws in our next video. And please remember to click on the subscribe channel to get hold of the latest Master Crammer videos. Thank you.